Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you some IIT problems of projectile motions. Students, if you watch my video regularly and follow my class attentively, I can assure you that you can crack the IIT exam and NEET with a good rank very easily. Now let's start about the class. Problem is a ball is projected from point A with velocity 10 meter per second perpendicular to the inclined plane as shown in this figure. The range of the ball on the inclined plane is what? 4 options are given. Which one is correct? This is the problem. This is the diagram. So solution of problem 1. This is the inclined plane. Okay. This is the inclined plane and a body is projected perpendicular from the inclined plane. Inclination is 30 degree. Then what is the range of this path? Range means this path. So if we draw I have said already in my videos that to solve this type of problem, resolve the velocity and acceleration along two directions x and y. Suppose we take this as x-axis and this is as y-axis. So the velocity, initial velocity along x-axis and initial velocity along y-axis, and acceleration along x-axis, acceleration along y-axis. So what is ux? Ux is completely zero because the body is projected perpendicular from the plane. So perpendicular, so this velocity uy, this is 10 meter per second. So ux completely zero, uy is 10. Now what is acceleration along to the x-axis? To find the acceleration, this is g, and this is 30 degree. So two component of acceleration here. This is ax and this is ay. So this is 30 degree. So this angle is 30 degree. Ax equal to what? Ax equal to g sin 30 degree and ay equal to minus g cos 30 degree. Okay. Now range, to find the range, that is A to B. First we find the time of flight. Along range means here initial point, here final point. Net displacement along y-axis is 0. So Sy equal to 0. Sy means equation in straight line. Uy t plus half ay t square equal to 0. That is uy equal to 10. Ay equal to g cos 30 degree. That is g cos 30 degree means 3 by 2. So ay equal to 5 minus put here 5 root 3. Ay t square equal to 0. So t equal to, from that we get, if we common t into 10 minus equal to 0. So t equal to 0 at here and t equal to this at here. So time of flight t equal to second. Displacement along x-axis sx equal to, we can easily write uxt plus half axt square. Equation of motion along straight line. We can easily write this. So now put ux equal to 0, t plus half ax equal to g sin 30 degree into t, we get this. So 5 half t square means 400 by 25 into 3. That is, so this is the answer. So answer is this. Now next problem is, in the projectile shown in figure, given TAB equal to 2 seconds. Suppose a body is projected at here, the path is this, the time taken to reach the particle from A to B is 2 seconds. Now, which one is correct? Particle is at point B 3 seconds. Maximum height of projectile is 20 meter. Initial vertical component of velocity is 20 meters per second. All option is correct. Which option is correct? So I repeat the problem once again. In the projectile shown in figure, TAB equal to 2 seconds. Means this to this is 2 seconds. The options are given. Particle is at point B. Particle is at point B at 3 seconds. Means the time taken to reach the particle from this to this point is 3 seconds. Maximum height, that is this height, is 20 meter. Initial vertical component of velocity 20 meter per second. All options is correct. So 4 options are given. Which one is correct? This is the problem. Now, if we want to solve this problem, so always resolve the velocity along x direction. So this is suppose theta. This angle is not given. Suppose this angle is theta. So what is the x component? U cos theta, and y component is u sin theta. You already know. U cos theta, u sin theta, and here g is along y direction and this is 0. So ux equal to u cos theta, uy equal to u sin theta, ax equal to 0, ay equal to minus g. Now here this is a projectile path. This is a projectile path. Now to coordinate of the point on the path is, the coordinate of point A is, we can easily write 20, 15. X coordinate 20, y coordinate 15. Again at B, coordinate of x coordinate will be 60, 20 plus 40, 60, and y coordinate 50. So these are the 2 points on the projectile path. Now, what is the equation of projectile path? If you cannot remember the equation, then you can easily find the equation of projectile path. First, how we get the equation of projectile path very easily. Don't have to remember the formula. Just x equal to u cos theta into t and y equal to u sin theta t minus half gt square. These are the 2 equations. So if we eliminate the t from this, we get the equation of projectile path. So this will be u sin theta t is x by u cos theta minus half gt. So this becomes this. So this is the projectile equation. This is the projectile equation. Now the point A and B on this equation. So this point satisfy the equation. So we can put x and y. This is x and this is y. This is x and this is y. We can put x and y in this equation. That is 2 points satisfy the equation of path. So we can put x and y coordinate at this equation. Now put this equal to x means 20 minus g by 2, that is 5 x square means 400 by u square cos square theta. Now cancelling 5 from both sides, 5, 3 equal to 4 tan theta minus 400 by u square cos square theta means sec square theta, cos square theta means sec square theta, and sec square theta means 1 plus tan square theta. So 3 equal to 4 tan square theta minus 400 u square, sec square theta means 1 plus tan square theta. or you can keep sec square theta, or sec square theta equal to 4 tan square theta minus 3 or minus 3, or u square equal to 400 sec square theta by minus 3. This is one equation. Now the point B also satisfies the equation y equal to this. This is the equation. So B also satisfies the equation. So y equal to 15 for B. Y equal to 15, x equal to 60 minus 5 into x square means 3600 by u square into sec square theta. So cancelling 15 from both sides, 4 15s, 1200. So u square equal to minus 1. Now this is 1, this is 2. So from 1 and 2 we get this equal to this. This is tan theta. Tan theta. So this by 4 tan theta minus 3. Now so 12 tan theta minus 9 equal to 4 tan theta minus 1, that is 8 tan theta equal to 8, or tan theta equal to 1. Tan theta equal to 1, that is theta equal to 45 degree. Now we get tan theta equal to 1, tan theta equal to 1, that is theta equal to 45 degree. Now A, that is point 20 15, x is 20 and y is 15. Put here x equal to 20, so 400 u square by cos square theta. Now if we put tan theta equal to 1, that is theta equal to 45 degree, so we get 15 equal to 21 minus this by u square cos square theta. Cos square 45 degree is half, that is 5 into 400 into 2 by u square equal to 20 minus 15, that is 5. So u square, we get u square equal to 5, 400 into 10 by 5, 2, 800, that is u equal to 20 into root 2. So now vertical component, that is this, vertical component is this, equal to vertical component sin theta, which is equal to 20 root 2 sin 45 degree 1 by root 2, that is 20. So vertical component, initial vertical component of velocity is 20 meter per second. Now what is the time taken to reach the point B? Now we get theta equal to 45 degree and u equal to this, and theta equal to 45 degree. So it is 60-15. So along horizontal direction the path is 60 meter. So we know distance equal to velocity into time. Along horizontal direction no acceleration, so simple u cos theta into t. So t equal to 60 by u equal to this into cos theta, cos 45 degree. So this is 3 second. So this option is also correct. Okay. Now maximum height of projection we get easily. H maximum equal to, for projectile motion we know that this equal to sin 45 degree 1 by root 2 square by g equal to 10, that is equal to u square by 2g. So put the value of u, this sin 45 degree 1 by root 2 by 2 into g is 10, that is 400 by 20, that is 20. So this option is also correct. So all the three option is correct. All option is correct. The final answer is this. All option is correct. So here problem is this. I repeat the problem once again. Two inclined plane OA and OB. Suppose this is OA and this is OB. Two inclined planes OA and OB intersect in a horizontal plane, having their inclination alpha and beta with the horizontal as shown in figure. So this is the horizontal. Two planes OA and OB inclined at angle alpha and beta with horizontal. Now a particle is projected from point P. A particle is projected from point P with along a direction perpendicular to plane OA. That is, OA is a plane and particle is projected from this plane perpendicularly. Okay, perpendicularly. The particle strikes plane OB perpendicular at Q. Suppose this is point Q. So here the particle strike the OB again at perpendicularly. This also perpendicular. This also perpendicular. Now a angle alpha and beta, value of angle alpha and beta given. So what is the time of flight from P to Q? So P to Q, that is from P to Q, the particle strike like this, so x component is 0. So find the time taken t to reach from P to Q. Now to solve this type of problem, I have said already that we have to resolve the velocity and acceleration component along two directions, x and y. So we take x and y axis as are convenient. So take, suppose this is x axis, and this is y axis. We take this is x axis and this is y axis. This is inclined plane and this is another inclined plane. A particle is projected with perpendicular. This is 90 degree. This angle is alpha. This angle is beta. Particle strike at this point perpendicularly. This is Q point. So we take x and y axis as our convenient. Now let this is x and this is y axis. This is x axis, this is y axis, because here the vertical component will be 0. So for that we take x axis and perpendicular to the plane is y axis. This will be more convenient because vertical component of the velocity, vertical means y velocity, velocity of y component will be here 0. So we take y along this direction. Now this is x. Shift this axis at here, shift this coordinate axis, this to this here. So if we shift this at here, then parallel to this is this and parallel to this is this. So this is x axis and this is y axis. Now what is the angle of this? We have to calculate now the angle of this. What is the angle of this? If this is alpha, we have to draw a horizontal line. Suppose if this is alpha, then this angle is alpha, alternate angle, and also this angle and this angle equal because this is corresponding angle. This angle beta equal, alpha equal. This is alternate angle and this is corresponding angle. So two angle is alpha plus beta. Now what is the angle? This angle is 90 degree. So what is this angle? Theta. Theta will be 90 minus alpha plus beta. Here this angle will be theta, that is 90 minus alpha minus beta. So along x direction u cos theta, which is equal to u cos of this means this, and uy equal to u sin theta, that is u cos of u sin of this means cos. This clear? Cos 90 minus this means sin this. So we get ux and uy, and also if we resolve the acceleration component along x and y, this is beta, so this angle is beta, and this is g sin beta, and this is g cos beta. We know that if this angle is beta, then this is 90, this is 90 minus beta, 90 minus beta is beta. So this angle is beta. Here this is g cos beta, g sin beta. So acceleration component dx equal to minus g sin beta and y component equal to minus g cos beta. So always we resolve velocity and acceleration component along x and y direction. Now the particle strike at this point q perpendicularly. That means velocity of x component will be 0 because the particle strike completely perpendicular. That is velocity along this direction should be 0. So vx of the particle will be 0. Final velocity along this direction should be 0. Now vx we can easily v equal to u plus at. So ux plus x into t equal to 0. So t equal to ux by minus ax. Now ux, what is ux? Ux equal to u sin alpha plus beta, and minus of x means g sin beta, that is g sin beta. So now if we put alpha equal to 30 and beta equal to 30, we get the result, time of flight. So if we put alpha and beta, we get t equal to u sin 30 plus 30, 60 degree by, that is by 2, u root 3 u by g. So this is the correct answer. We always resolve velocity and acceleration component along x and y direction, and we take x and y direction as our coordinate. So the choice of the coordinate, the choice of the x and y coordinate here will be more important to solve this type of problems. So this is the problem. I repeat the problem once again. A large heavy box is sliding without friction. Suppose this is the plane. A box is on the plane and it is sliding without friction down a smooth plane of inclination theta. Inclination is theta from a point P on the bottom of the box. Suppose here is a point on the bottom of the box. A particle is projected with velocity u at an angle alpha. A particle is projected inside the box. The initial speed of the particle with respect to the box is u. That is, this is very important. That is, the question is giving the particle with respect to the box. The particle is projected with respect to the box u, and the direction of projection makes an angle alpha with the bottom as shown figure. This is the diagram. This is the diagram. Here question is find the displacement, find the distance along the bottom of box between the point and of projection and the point q for the particle length. That is t to q. Suppose this is here length here. So you have to find the distance pq and neglect here distance and the particle does not hit at any other surface. Assume this. And second question is, if the horizontal displacement of the particle as seen by an observer on the ground is 0, suppose here a observer is present, he observed that net horizontal displacement of the particle is 0. Find the speed of the box with respect to the ground at the instant when the particle was projected. Find the speed of the box with respect to the ground at the instant when the particle was projected. So this is the question. Here two motion is given. To solve this problem, we have to consider two velocity. One is velocity of box. Solution: velocity of box with respect to ground equal to suppose v, that is in this direction v, and velocity of particle with respect to ground is, suppose this is v, suppose this is u1. We take the velocity of particle with respect to ground is u1 and velocity of box with respect to ground is v. Now, as we just discussed that take x and y axis as a convenience. So take x axis. So take x axis along this direction and y direction and y axis along this direction. This is x axis and this is y axis. Now, u1 with respect to alpha. So what is the x component of the particle? What is the velocity of box with respect to, what is the velocity of particle with respect to box? So velocity of particle with respect to box along x direction will be, suppose this is u1, so suppose this is u1 and alpha, so this is x and this is y, so this component will be u1 cos alpha and this is u1 sin alpha, and along x axis box is completely v and along y axis this is 0. So along x axis the velocity of particle with respect to box will be u1 cos alpha minus v, because this is positive, this is negative, so we take here. Also if we take I unit vector along x axis, then this becomes this, so this is magnitude is this. So u1, this is the velocity of particle with respect to box. Now here giving velocity of particle with respect to box is u. So with respect to, so this component is u cos alpha. So we can easily write that u1 cos alpha plus v equal to u1 sin alpha. U. So we can write that u1 cos alpha plus v equal to u cos alpha. This and this equal, and velocity along y-axis, that is u1 sin alpha minus here velocity along y-axis of the velocity of the box along y-axis becomes 0, because velocity of the box completely along negative x-axis. There is no component along y-axis. So this equal to, here we get sin alpha. To find the range PQ, to find the range PQ, we know that for Sy equal to 0, so we can easily write uy into t plus half ay t square equal to 0. So take common t, uy plus ay t by 2 equal to 0. Now we have to resolve the acceleration component. Suppose here acceleration is giving acceleration g, act in this direction, this is g, so this is y direction, this is x direction, this is theta, so this component will be g cos theta and this will be g sin theta. This is g cos theta, this is g sin theta. So acceleration along y direction is minus g cos theta, and acceleration along x direction is minus g sin theta. This is particle. For particle, and for box, acceleration along y-axis is 0 and acceleration along x-axis is equal to minus g sin theta. For particle, the acceleration component, and for box, acceleration component. Now, here we have to consider the particle with respect to box. Now, from this we get, this is the velocity of particle along y direction. So what is uy? Uy equal to uy. We get uy equal to uy. This u1 sin alpha minus, this is the velocity of particle with respect to box. So this, now this equal to by ay. Ay means this, that is plus. Now this equal to u1 sin alpha minus 0 equal to u sin alpha. So this is the time taken. This is the time taken to reach the particle from this to this, time taken. Now what is the range? Range is displacement along x-axis. Now what is the range? Range PQ equal to distance moved along x-axis. Here x-axis is here, not this. Here x-axis is here. This is y-axis. Along x-axis, that is u1 cos alpha plus v. This is the with respect to box. We have to consider velocity with respect to box into time taken. Now this time we consider this time. So this equal to actually u cos alpha into p equal to this. So answer will be this. Answer will be this. U square 2 sin alpha cos alpha is sin 2 alpha by g cos theta. This is one answer. Now, if the horizontal component becomes 0, now next question for B. This is angle theta, this is angle theta, this is angle alpha, u velocity with respect to box. Now the velocity of the box is along completely this, and velocity of the particle here is along this direction. This is, if this is angle theta, this angle is theta, so this component will be u cos theta plus alpha. This is with respect to box. Now velocity of this along this direction, this component is, this is theta, alternate angle, so this is v cos theta. Now this component with respect to box, now this is the velocity of box, so velocity of particle with respect, so this is the velocity of particle with respect to box, this direction, and this is the velocity of box completely this. So this is the velocity of particle with respect to box, and this is the velocity of box. Now two velocities should be equal as the observer from the ground observe that there is no horizontal displacement. So as there is no horizontal displacement, this velocity should be equal to this. So u cos theta plus alpha equal to v cos theta. So v equal to this is the answer. So velocity of the box should be equal to this, such that an observer on the ground see that there is no horizontal displacement of the particle. So this is